I tried to do a problem and I screwed it up. So I'm redoing this video, and I'm going to do a function f of x equals 3x squared minus 2x plus 1. You may look at that and go, oh no, that looks really scary. But just remember that we're going to take it step by step, bit by bit, and we'll figure it out as we go. So I'm going to, for the first step, I'm going to use orange. Step 1 is f of x plus h. Let's just forget the one. So that's going to be in orange, my little orange UT pen here. And black will be for minus f of x, which is our original function, and I have a pencil. I don't have another pen. Charlotte probably has other pens, but we use pencil to denote our h, or our change in x. So it doesn't really look that much different. I suppose it doesn't really matter. The important thing is that this because it's there's two terms, once we put it into a polynomial like this, it becomes really, really big and messy. And so I just want to give you a way to separate this from that. Because once you add on the original function, it becomes even bigger. So let's take it simple. Step 1. F of x plus h equals, and all you're doing here is you're taking this value and you're substituting it in for each x. So you can think of these as having parentheses around them. And you're just inside the parentheses, you're putting this new value, which is x plus h. So new input, x plus h. That's what that is. Just wanted to reiterate that. So your original function is 3, and then in parentheses you put x plus h, and then that was the squared minus 2 times x plus 1. I'm sorry, 2x plus h. I'm sorry, 2 times x plus h plus 1. Because you're substituting it in for each x. Don't make that same mistake that I did, because it's hard when you're dealing with multiple terms here, especially if I'm sorry, it's going to confuse you, but just double check and double check so you don't lose any terms, or as the teacher said in recitation, like, ooh, I go around and I drop my limit. I'm like, huh, drop your limit. Oops, I dropped my limit. Sorry, guys. But anyway, I'm not going to drop my limit. I'm going to get this right. So we're going to simplify this. So we're going to write this out. 3x plus h becomes 3 times x squared plus 2xh plus h squared, and all of that times 3. So you multiply that in, 3x squared plus 3 times 2 is 6, 6x h plus 3h squared. Okay, now there's this part, minus 2, and then you multiply that into each thing, so 2x, and then negative 2 times h is minus 2h, right? Yeah, because if you multiply it in, if you take the negative out and multiply that in, it becomes 2 plus 2x plus 2h. And then if you multiply, or if you subtract that whole quantity, it becomes negative 2x minus negative 2h. Or minus 2x minus 2h. And then dr plus 1 plus 1. So it's a big long expression, and we're only on step 1. I know it's freaky messy, but it's nothing we can do about that at the moment. You can't combine any terms. You could factor things out, but there's no reason to. At this point, step 1 is complete, and I'm just going to use a pencil to circle this. There's step 1. And so step 2, actually, I'm going to erase that line that I just made and use this for step 2. Step 2 is take this and we're going to subtract, like up here, we're going to subtract f of x. So that's this function right here. We're going to just plug it in right there. So 3x squared. I'm going to put this in parentheses so we don't make a mistake with the sign. Minus 2x plus 1. And you multiply that in, you get negative 3x squared. Negative times a negative is a positive, plus 2x. And then negative times positive is a negative, minus 1. So let's put this in orange here. 3x squared plus 6xh plus 3h squared minus 2x minus 2h. Big long thing, plus 1. Remember, this is just f of x plus h. That's all that is, really. It's just we could leave it factored, but this is going to help us find terms to cancel out, and that's why we don't want it factored. Man, this video is going to be long. Okay, so, and then you have that plus 1 minus 3x squared plus 2x minus 1, which is, we distributed the negative into this original formula. So now you see things that you can match up. 3x squared minus 3x squared, that cancels out. And then you have minus 2x here and plus 2x here, cancel out. I'm sorry, not h. Leave the h. 2x. Okay. So you have minus 2h plus 1. And then you have plus 1 here, and minus 1 here. So you're left here, these terms here. And at this point, I'm going to stop using the orange pen because at this point we've crossed out terms and simplified things. And so now we can say 6xh plus 3h squared, and minus, we have to include that because I forgot, minus 2h. Yeah, and that's it. So that is your answer to number 2. And since this is smaller, I'm going to just write it again for number 3. So step 3 is you're dividing it by h. You're putting the over h there. So you've got, and the reason why we're doing this is in steps is because if you try doing this in one whole big thing, this long expression would become an even bigger expression because you're now dividing it. And that's why the steps can be useful if you're overwhelmed by a big formula with a big polynomial like that. So we've got 6, actually we can rearrange this and move the 3h squared and then minus 2h plus 6xh. So 3h squared minus 2h plus 6xh. And you're going to divide that by h. And you see a common factor here, h, h, h. And this time I'm actually going to write it out. Last time I didn't. 3h. You can pull an h out of here, pull an h out of here, pull an h out of here. So 3h squared becomes 3h. We're going to multiply it by h here. And then the minus 2h becomes minus 2. and then I just had to think of whether I was going to switch them or not, but I'm not. And then plus 6xh becomes plus 6x. And so you have that over h, and look at that, you can cancel out h. So you're left with 3h, we'll rearrange it now, plus 6x minus 2. And you're saying, well, why is that, like, why are there two variables in there? Well, this is where step 4 comes in. Step 4, we're finding the limit as h approaches 0, or the change in x approaches 0. And so you just plug in 0 to this over here. So it becomes 3 times 0 plus 6x minus 2. And that simplifies, so 3 times 0 is 0, plus 6x is 6x, and minus 2. And there you go. There's your derivative. Equals f prime of x. So, that's a big, lengthy process. And I'm going to add on to the original what is the derivative of this function and say use the slope of the tangent line, which, remember, that's what your derivative is. The slope of the tangent line is the derivative. And the derivative formula right here, the resulting formula, is used to find the slope of the tangent line at any point of x. So any x value plug in here on the function, you're going to get a derivative. Or you're going to get the slope of the tangent line at that point. So you can use it like when we said here, when you have a graph that, you know, the slope of the line here and then the slope of the line here, you're going to be able to, this function will define this line, it'll define this line, it'll find that line, whatever tangent line you can make, it will find the slope of that line by plugging in the x value at the point that it intersects the graph. So let's say that you were given a point on the graph 3, okay? 3 is x and y is 1, okay? So 3, 1, x equals 3, y equals 1. So you just simply plug it in, plug 3, which is your x, into this, into your derivative. That'll give you the slope of the tangent line. 6 times 3 minus 2, that's 18, minus 2, which is 16. So 16, that number is going to be really important. And I'm going to say, remember the slope equation, the slope-intercept form, y equals, can you see it here? Y equals mx plus b. Remember that? That's y value, or we could call it f of x, equals the slope, m, times the x value plus the y-intercept. And once, if you're given a point 3, 1, you have x here, you have y here, and you have, oh my, this video is long, and you have m from here. So 16 is our slope, and that's m. So when they ask you to write an equation of the tangent line at that point, you're going to use this y equals mx plus b, this value, this value, this value, to determine what b is, and then that way you can write your generic formula for the line. Now I'm going to use my Spanish notebook here because I'm running out of room on this page, and I still want you to see the problem. Let me zoom out a little bit. Okay, and once this is done, I'm going to say goodbye for the night because it's getting late and you guys probably don't want to watch hours and hours of video footage of me just rambling on about math. So we got this here. So you've got 18 minus 2, 16. Yeah, 16. So let's write down the values we know. At that point, y equals, from here, it's 1 equals 1. X equals, right here, 3. That's given to us. M, we just figured out, is 16. M equals 16. B equals, we don't know yet. That's what we're finding out. We have a simple formula that'll tell us what that is. And so we don't even need this function up here anymore. We know the 3 values, and it's a simple algebra problem to figure out the last value. So y equals mx plus b equals, or that now becomes 1, because we substitute 1 for y, 3 for x, equal, or 16 for m, equals 16 times x, which is 3, plus b. And 3 times 16, I don't know that off the top of my head. 3 times 6 is 18, plus 3 times 10 is 30, 48. If I'm wrong, please sue me. I'm just kidding, don't do that. Okay. 48. Yeah. I think that's right, right? 3 times 6 is... Whenever I have problems like this, I always have to write them out. And it's gonna drive me crazy until I figure it out. Yeah, 48, okay. I just wanted to make sure, not confusing you guys at all. Plus b equals 1, because that's our y. So now you just subtract 48 from both sides. It's rather large. Minus 48, and you get 1 minus 48, which is not 1. You get minus 47. Yeah, I checked that for a second. Equals b. So now you know b. So b is now negative 47, which is kind of a big number. Well, big in magnitude, small in value. So now now we know we don't need the point anymore. We've got our shift, or our not shift, sorry. We got our y-intercept, and we have our slope. And that's all we need to write a generic formula for the slope of the tangent line at that point, which is y, or f of x, you could say, but on our homework it's y. Y equals 16x plus b. Notice I didn't plug these values in anymore, because we don't need to. It doesn't matter. This is the slope of the line. Or, sorry, not b. Minus 47. Okay, yeah. Y equals 16x minus 47. I was thinking so much about not putting in x and y that I didn't write the b correctly. And there's your value right there. I don't think that can be factored. But yeah, that's your and that would be slope for the line at that point. And just to show you guys what I mean by this, I'm going to pull it up on my computer, which evidently has fallen asleep. Oh my, this is getting really long. Come on. Okay. So now let's go back to the home page. Take me back to the home page. There we go. Okay. I'll take that line off, and we'll put in a new function, which is our original 3x squared. Squared minus 2x plus 1. And it looks like that. That's our graph of our function. Man. You can zoom out. No, it doesn't make it better. It makes it worse. Okay, so so there's our function, and the point that we had was 3, 1. Oh my, that point is not even on that graph. Isn't that lovely? Well, didn't think that one through. I'm sorry, guys. Okay, give me a second, I'll pause the video and I'll figure out a new point and show you that it works. I'm sorry. Well, I make mistakes too. Okay, I fixed my problem. What I did was I took a value of x and I made it simpler, like x equals 1. And I plugged it into our little slope-intercept form thing. Actually, I plugged it into the original function and I got that y equals 2 and x equals 1. And then I used those values to do the same process that we did before, except I didn't get 16x minus 47, I've got 16x minus 14. And you can see when we type the equation of that, 16x minus 14. Oh, that's not right. Hold on. Okay, I'm gonna go back up a few steps for myself, not on camera, and I'm gonna get a new value. I'll use x1, y2, but I won't. It won't be 16x minus 14. Let me delete that. Okay, I'm back, and I've got one that works. Finally, I had to go back and, as you see here, our derivative that we found, right there. I had to plug in the new value of x, which is 1, in there to get the new slope, which is the new m, which is 4, and then I plugged it in to right here. I plugged it in to the formula slope at intercept form, and I get b, to figure out what b was, -2, so then I put it in here, y equals 4x minus 2, and you can see on the graph when I graph this on the graph, I get this here. And you can see that point where they intersect is 1, 2. And you'll see as we get really close to this point, the slope of this line and the slope of the function get closer and closer together. They become more and more the same. And that's your derivative. So that'll tell you what that function is doing at that line. Now in the next chapter, it talks about some rules of functions, which will make these calculations much easier and take much less time. I'm going to make another video on it. You guys are free to watch it, but I'm going to end my topic of derivatives here. I'm sorry if I confused you. Again, let me know if you have any questions, or you want me to make up a rigorous plan before I do these videos in the future so that I don't end up confusing you even more and taking up more of your time. I know time is precious as a student, so I'm going to let you go. Alright, see you guys.